So we're thinking here about taking what you know already about proportions and sort of converting it into more real life settings, if you will, with some of these word problems. So proportions, as we see here, can be solved to use word problems in which there is a constant rate. So if it's growing proportionally, then you can use proportions to solve. So it's really super duper. The most important part is to make sure that you're consistent when you set up your proportion. The units must match on each side of the equal sign. Okay, it seems kind of obvious, right? But it's really important and it's super common for it to get mixed up as you're sort of taking this information from your word problem. So, which of the following equations is a valid proportion? Is it true that miles to hours is the same as hours to miles? Is it the same that miles to hours is the same as miles to hours? Well, again, it might seem really obvious, right? But this is equivalent. This is not equivalent. So it can be really helpful to set up a key when you're writing your proportions to make sure you have miles to hours or whatever it is that you're comparing so that you can keep nice and tidy on each side of your equal sign. So in this example here, right, we're going to solve each word problem using a proportion. If we need to, we're going to round to the nearest tenth or the nearest cent when it's something that we need to do. So we know that we have the ratio of hot dogs to hamburgers, HBs, hamburgers, sold at a baseball stadium is an 8-to-3 ratio. Okay, so if we know then, so this is what we're given. If 272 hot dogs, well, hot dogs are in our numerator spot. Hot dogs is 272 hot dogs. Hot diggity, that's a lot of dogs. Were sold, how many hamburgers were sold? This is our mystery. So if we then say these are equivalent, right? An 8-to-3 ratio is the same as whatever this is, our 272 to our mystery. We can call it an X when we're solving this proportion. So what we know we can do is to set this up to solve using a proportion, we can do our cross multiplying. So we can say 8 times X is equivalent to 3 times 272. So we can combine our like terms. We don't have more than one x, so there's nothing to do there, but 3 times 272 can be simplified through multiplying. So when we multiply them, we end up with 816 equals the same as 8 x's, 8 of our little mysteries. So in that case, x, our mystery, is feeling a little trapped, right? We want x. X wants some personal space. We want to get x all by itself. We want to know what just one x is worth. So to do that, right now 8 and x are connected by multiplication because they're touching. To undo multiplication, the inverse operation, the opposite operation is division. So we are going to divide 8 by 8, which gets us 1. And now we have our 1x. It's so happy by itself over here. Legal to do so long as whatever you do to one side, you do the same to the other. So we need to now divide this by 8. Well, 16 divided by 8 is 2, and 8 divided by 8 is 1. So we end up here with 12, but that doesn't make sense. So this needs to end up actually being an 800. So this is a 102. So 1x is equivalent to 102. So what does that mean for our sentence? Well, if we go back up and we say x equals 102, we're going to say that for every 272 hot dogs that were sold, there were 102 hamburgers that were sold. We can also check it by putting this, our x, into our original physical setup. So if we say x, you are no longer a mystery, you are 102. When you do 8 times 102, you should equal the same thing as 3 times 272. So you could say, does 816, 8 times 102, equal the same thing as 800